Yes, thank you for the introduction. Day 3 of Aquanor. Happy to see still some enthusiastic people attending this arrangement. My name is Tarald Kleppa Øvrebø, and I'm an R&D manager in a company called Harbor. And I will present for you today the harbor fence technology, and I will also show you some results from reducing the sea lice pressure on a commercial scale in Norway, and also show you some interesting findings on inactivating jellyfish by introducing pulse technology. But first, let's look at the harbor fence. So the harbor fence is a barrier that's surrounding the net pen, and we are introducing the electrical pulses by generating electricity through special-made electrodes. And those electrodes are creating pulses 20 times per second. So it's super fast pulsation surrounding the whole net pen. And we have done a lot of work in lab in collaboration with Norse and SINTEF, and we have validated and actually proven that electricity will inactivate the early stages of the sea lice. So the harbor fence are looking into reducing the impact on Nauplii 1 and 2 and copepodids. So we are targeting the infectious stages before entering the main host, which is in this case is the salmon. The harbor fence is 10-meter depth. So the electrodes are 10-meter depth surrounding the net pen. And the effect of harbor fence is also reducing the overall pressure on the site with harbor fence, but also reducing the overall pressure on the neighboring site. And again, we have done a lot of R&D with Norse and SINTEF when we're looking into how will the pulse train, when exposed to fish and the salmon, what will the salmon be stressed? And because we're working in a low area of the frequency, the parasite finds it quite harsh, the pulse train, but the fish will not have the same stressor when exposed to it. And the harbor fence is hanging outside the net pen. We have today 20 harbor fence in sea in Norway, and I will give you a brief introduction of some preliminary results regarding the sea lice pressure. As you all know, the sea lice is a huge challenge for Norwegian farmers, and we have limited mitigations. We have the stingray, we have the blue lice, we have the harbor fence, and we have cleaner fish, and maybe we have lice skirts as well. But that's 5 to 6 mitigations you can use to try to do something about the sea lice pressure. Here we are situated in the western coast in Norway. This farmer had fish inside the cages for 9 months, and then they wanted to test if harbor fence can reduce the overall pressure regarding the lice pressure, because then now they are going into the summer season, and they wanted to test if harbor fence can reduce the overall pressure. And they're using cleaner fish as a mitigation, and they wanted to test if harbor fence plus cleaner fish would have a significant effect on reducing the lice pressure. This is a bit fascinating site because it's anchored at one point, meaning it always drifts against the main dominant current. So historically, the 4 cages that you can see where we have deployed the harbor fence are the most, have the highest lice pressure. And we installed the harbor fence in week 10. This site has had 1 delousing treatment before we installed the harbor fence. And you can actually see the effect of how reducing the overall pressure helping the cleaner fish doing a better job. Because in this period, there's no more delousing done. And we also wanted to see how is the overall pressure in the fjord, in the basin. So we did a comparison. This is the site A with harbor fence and cleaner fish. They had undergone 1.5 delousing treatment. And in comparison with the neighboring site, there's on average 5 delousing treatment in the same period. And all of those sites also have mitigations such as cleaner fish or new technology. And the interesting part is that those were the worst, most heavily impacted on sea lice pressure before installing the harbor fence. Now, they're the best one. And actually, the lice pressure situated to the other net pens, but those four had the lowest lice pressure after the deployment of harbor fence. So far, this is an ongoing preliminary trial, but the promising result is that our main goal is to reduce the number of delousing treatment the industry need to do. And so far, looks good. But we still want to thoroughly identify and understand what are the pulse train doing. This is a couple of bits, and now we can see we're turning on the pulse train. Now, and you can see it disturbs the parasite. And we're doing our R&D trial with Norse now, looking at the gene expression. We are doing several trials trying to see what are the voltage, what kind of pulse train will give even better results in mitigating the copper-bodied stages. And also, we are doing a large field trial with Samak in Finnmark. We're deploying the harbor fence this week, actually. And Norsk Reinsentral will be part of that R&D trial and try to do the maths behind the effect. But regarding reduction of infectious stages, we think preventive technology is super important in combination with, for instance, cleaner fish or a stingray. Because as you know, a cleaner fish will probably be something that will not be available for the farmers in the future. Okay, so in Norway, we have a problem with sea lice. And for the last couple of years, we also have a lot of problem with jellyfish, especially Apulmi uvaria, the perlesnormanet. And 2 years ago, we created a hypothesis asking the question, could a pulse train trigger the poison inside the jellyfish before entering the net pen? And here you can see the stingray, the sting jellyfish, Apulmi uvaria. It's a fascinating kind of jellyfish. It's highly poisoned, and it's not been common in Norwegian fjords before. And again, probably, as mentioned earlier today, it's correlated to the sea temperature, etc. It's been a huge challenge for Norwegian farmers, also in Scotland, etc. So we started looking into literature. We find out that some guys in Australia actually have done a lot of R&D on anemones. And anemones in jellyfish are quite nearly selected. And you can see the arrows going out from the tentacle. The arrows, or the kinetoblast, is the same kind of arrows hitting your skin when you attach a jellyfish in the sea. That's the poison going into your skin. So the question is, can the harbor fence pulse trigger that nematocyst before entering the fish and harm the fish? And actually, you can see in this video, you're able to see the poison coming out of the kinetoblast. There you can see it, and that's the same poison going into your skin. Okay. We applied for our project with FIF, and that was funded in collaboration with the JellySafe project. In the JellySafe project, we have SINTEF, and HI IMR is also a part of this project. So we started collecting a lot of Apulmi uvaria and introducing pulse train on them to see could we trigger the kinetoblast inside the jellyfish. And this is filmed from the microscope in collaboration with Nofima. And now we're trying to modify the pulse train, seeing that actually the Apulmi uvaria has 4 kind of kinetoblast, one to probably harm something, one to collect food, and we are triggering all of them. So this is the one you've seen in the picture. This is the kinetoblast going into the net pen and harming the fish and stressing them, causing high mortality and it's a huge challenge for the industry when they're emerging in the pen. Okay, so we try to modify the pulse train. Could one harbor fence pulse trigger the whole jellyfish? Yes, it could. And okay, you can do it in the lab. Let's see how will that apply on fish. So in collaboration with the JellySafe project, we did a project in Matre, north of Bergen. We had 150 smolt. 30 of the smolt was not exposed to anything. 90 of the smolts was exposed to fresh Paulsnormanet, Apolme uvaria. And 30 of the fish was exposed to Apolme uvaria, but harbor fence triggered Apolme uvaria. So we taste the jellyfish and we exposed them on the gills, on the head, and on the side of all of the fish. And if the harbor fence works, then none of those 30 fish should be injured or have visual wounds. And this is the results after 2 weeks. None of the harbor fence fish had any visual source, meaning that actually this validates that a pulse train or electricity can trigger the nematocyst or cnidoblast inside jellyfish. This is super exciting for us, and we also have installed several harbor fence in Finnmark as a result of these findings in collaboration with IMR. So we are a small company trying to mitigate the infectious stages of sea lice, but also we have some super interesting findings regarding mitigating the jellyfish problem. And thanks to the Norwegian farmers testing us, helping us develop new technology for the aquaculture industry. Thank you.
Thank you so much, Tarald. Do we have any questions?
Hi, thank you so much. Joanna from Sintef Ocean. Thank you for your presentation. My question is just, could this electromagnetic field caused by the harbor fence also harm nauplii from zooplankton that is naturally in the water? And have you evaluated for this? Or do you have any thoughts on it? Thanks.
So we're doing a trial now in non-target species as well, because we're trying to further understand what are we doing with other organisms. And we've done a project on hydroids as well. So we think that organisms that have a cnidoblast or a kind of nestle cell similar to the jellyfish will probably be affected. But that could also be beneficial regarding gill health inside the net pens. But of course, rødåte, cod, that is something we are running into a new project now. I mean, looking into non-target species, because that's a relevant question.
Yeah, sorry, but in the meantime, you already deployed these fences in several locations, and you haven't yet been sure about the consequences for what's actually in the water then. So these fences have already been deployed in some sites, like you have explained.
Yeah.
Okay.
We have one more question.
Hi, Phil James, Nafima. Super interesting, thanks. You, in the trial you had, you didn't actually enclose the cages. Is that a restriction for the, you know, how big a scale can you do? Can you enclose an entire farm, or?
Yeah.
Yeah. So
this farmer, we're employing on a new site, and then 100% fully enclosed, because we wanted to see that if there's a difference between on the site, but we are building like sections of the harbor fence, so we can have this on a full scale, 160 meters as well.
Thank you.